Okay, so I wanted to show you one more example, just to look at a situation where the decision is different. So again, I went ahead and set this up for you, since you should be pretty comfortable with that up to this point. The claim was greater than 6.5, and so that went in the alternative hypothesis because it did not contain equality. I went ahead and set up my rejection region, and again, I am using Z because I am given a population standard deviation. So sigma is known. That's how I know that I can use Z. And then notice in this case I'm shading in the right tail of the curve because the alternative hypothesis contained greater than. Okay, so when that happens, when I have a right tail test, I have to note that the level of significance, although it does give me an area, it gives me an area to the right. And if we're going to find Z, we have to have an area to the left. So like we talked about last class in a right tail test, I'm going to subtract that level of significance from 1 to get area left, and that's what I'm going to take to my table. Okay, so I'm going to go to my standard normal table with an area of 0.99. I'm going to get as close as I can to that area of 0.99, and that's going to happen right here at 0.9901. And that's going to correspond to a Z-score of positive 2.33. All right, so that's going to tell me my critical value is 2.33. And the rejection region would be anything greater than 2.33. So now we're going to go ahead and calculate our Z-score to see if it's greater than 2.33. We're going to look at our sample data. And the sample data has a mean of 6.8. So the sample mean X bar is 6.8. I'm going to take that and subtract mu, which is what I'm testing, at 6.5. And then I'm going to divide that by standard deviation. Okay, and again, for sample means, we take the standard deviation, which is 2.1, and then we divide that by the square root of our sample size. And in this case, we took a sample of 60 people. All right, so again, I'm going to go ahead and work that out in steps. So I'm going to take that standard deviation of 2.1, and I'm going to divide that by the square root of 60. And that's going to give me a new standard deviation of approximately 0.2711. And I'm going to take that numerator, which is 0.3, and divide it by that standard deviation. And that's going to give me a Z-score here, rounded to two places of 1.11. Okay, so now remember how we make our decision. We take that calculated Z-score and we compare it to our rejection region. And this time, 1.11 is not in the shaded region because notice the shaded region is greater than 2.33. And 1.11 is somewhere back here. It's less than 2.33. Okay, so it is in the non-shaded region. Now, like I said before, the test wants to reject the null hypothesis. That's what it's set up to do. And so when the value of Z is not in the shaded rejection region, that basically means that the test has failed to do what it was set up to do. So what we're going to state here is that we fail to reject the null hypothesis. Okay, that's anytime you're not in the shaded region, you fail to reject the null hypothesis. Now, when you fail to reject the null hypothesis, like I said, it kind of means the test fails. It means the test is inconclusive. So you know how before I've been stating there is enough evidence, but when the test fails, there is not enough evidence. And then to finish this out, you do the same thing that you did in the previous test. Because our claim is in the alternative hypothesis, this test was looking to support that claim. Now, it wasn't able to do that because the test failed, and that's why our interpretation here says there is not enough evidence to support the claim that mean is greater than 6.5. Okay, and again, while you're getting used to the interpretation, you can always come back here and reference my flow chart. So in this case, all right, we were back to a situation where the claim was in the alternative, it was greater than, no equality. But this time our test failed to reject the null hypothesis. So notice my interpretation right here said there is not enough evidence, test was inconclusive, to support that claim.